Okay, so in this problem, it doesn't mention ideal gas law, it doesn't mention R, it doesn't mention moles, right? None of that stuff. So that means we're going to use the original kind of problem from this chapter, which was, oh, let me change that color. Okay, it doesn't talk about moles, so we get rid of moles, and we're not using ideal gas law, so we're not going to use R. So we're just talking about temperature, pressure. It says find the volume, and it says at STP, right? So this is another temperature and pressure. So that's the equation we're going to use, all right? And we need some numbers for this. And we need to talk about if we need to convert things and what we need to convert. So first of all, the standard temperature is 273 Kelvin. And in this chapter, everything has to be Kelvin. So we do need to convert this from Celsius to Kelvin. So that's going to be an 8, that's a 4, 3, 348 Kelvin. I hope if I can add correctly. And the other thing we have here is pressure. Now, because we're not using R, we don't need to convert it into ATM. So what I would recommend you do is just leave it the way it is, because that'll take time if you convert it. And you can, at STP, there is a standard for millimeters of mercury, which is 760. So we now have T1, P1, we're looking for V1, we have a T2, we have a P2, oh, just kidding, here we go, here's our V1, it's milliliters here, this is our V2, there we go. So now we can just plug it in. And you can do this two ways. You can plug it right into this equation, which now doesn't have R and T, plug it in, solve for V2, or you can rearrange this equation so it's just V2 equals something. I'm going to rearrange it so I don't have to write as much later on. So V2 is on the bottom, so I'm going to bring it to the top by multiplying V2 on both sides. So it'll cancel out over here. Now V2 is over on this side. Now I just have these T's I need to get to the other side. So I'm going to divide by T1 on each side. All right, so that's going to get rid of T1. And then I'm going to multiply by T2 on each side. So I'll bring T2 over here, get rid of our T2s, and this looks like a bunch of mess, so I'm going to rewrite it. I'm going to put V2 here, and V2 equals P1 V1 T2 over P2 T1, all right? And if you don't like doing it that way, that's fine. Just plug in all the numbers from the equation here and then cross multiply and solve your problem. You can definitely do it that way as well. All right, so let's plug in some numbers. P1, what's our first pressure? 688. What is our V1? 820. And that's in milliliters. Again, because we're not using R, we don't need to convert all this stuff. The only thing we need is the temperature to be in Kelvin. So we have T2, which is 273 Kelvin. On the bottom, we have our second pressure, which is 760. And then we have our temperature, which is T1, which is 348. Okay, any questions so far with setting this up? You guys pretty good? Okay, let's cancel out some units. Let's plug it in the calculator. And let's make sure we get the right answer. So now we're going to get milliliters because that's the only thing that we didn't cancel out. And we're going to do 688 times 820 times 273 equals a huge number divided by 760 divided by 348 gives me 582. Did you guys get 582? Yeah? Alright, awesome. Let's look at sig figs. This only has 2 sig figs, so we need to have 2 sig figs in our answer, so it's going to be 580. Everything else looks pretty good. 580 milliliters
That's our V2.